And I'll just briefly introduce the organization I'm here representing. So the Clean Energy Buyers Association and the Clean Energy Buyers Institute. It's a family of 2 organizations. We have a mission to achieve a 90% carbon-free U.S. electric grid by 2030. Extremely ambitious. And what this entails is not just bringing more wind and solar online, but also making sure we bring in battery storage and other sources of clean power, so that no matter what time of day you turn on the switch, you know that you're sourcing your electricity with clean power. And we also represent the world's largest community of clean energy customers, companies who buy clean power and then companies who provide the solutions for clean power. So Alan talked a little bit about clean energy, and I just want to double down on this because this is something that can be quite complex, and I want to try to make it really clear for folks how these markets work. So right now, if you're a company and you power up your operations, you're using the standard grid mix. And in the standard grid mix, there's a whole bunch of generators that come from a whole bunch of different sources, whether it's coal, gas, nuclear, hydro, wind, solar, et cetera. And you don't really know what's powering your facility. And that's because our grid is like a big soup of electrons. And so essentially, with the status quo, were there no market for clean energy, if we just accepted the status quo, we'd have to depend on policy outcomes to move things faster. So luckily, about 15 or so years ago, we started creating these things called voluntary clean energy markets. And so what that does is it allows companies to take a proactive measure to buy clean power. But because we're dealing with an invisible product, how in the world do you actually do that? And it gets quite complex really quickly. So to create a clean energy market, what we have to do is we have to essentially tag all the clean energy facilities, like the solar, the wind, the hydro, all the non-polluting sources, put them in a database as it is today, and then every month say how much did each of those facilities produce, create a REC, a renewable energy certificate, like what Alan was talking about, that represents 1 megawatt hour of clean electricity. And then each of those facility owners of the clean energy facilities can sell those. Essentially becomes a new source of revenues. It makes clean energy more profitable than it otherwise would have been. And then there's a whole market of companies who buy these certificates to then say, ultimately, I'm 100% clean powered if their electricity use equals the number of certificates they have in their accounts. But as Alan was talking about earlier, the way this is all set up is a situation with walled gardens, systems that don't talk to one another. So you can probably see kind of where I'm going with this conversation. But at the end of the day, how this works is that, let's say you're a particular company, this little blue person here, there was a wind facility that was tagged, there was a certain amount of megawatt hours that were confirmed it produced, a certain amount of then renewable energy certificates, and then this particular company bought them, and they know that even though there's this big soup, they can control what comes to their office, they bought a property right over the greenness of the electrons that went into the system, again, providing that incentive to help displace coal, gas, and other polluting sources from the grid. And so this is at the bones of how voluntary markets work, and it's the way that you can take a measure beyond, it's a way to vote with your dollars rather than just voting with your votes for having different outcomes on where our electric grids go. And so to date, there's been one standard set of things companies do to procure clean energy. Essentially, the way the global clean energy system is designed, the way I was just explaining it, it incentivizes annual clean energy purchases by companies. Essentially, household brand names you can think of, they buy clean energy once per year based on their annual energy use, based on where they're consuming electricity around the world. And essentially, they're incentivized to buy wind or solar once a year. And that's just how it is. But we at SxSW know that we need to do much more than just putting more wind and solar on to achieve a fully decarbonized grid. We need batteries. We need solar and wind, not just in places like Texas. Texas has been leading the way in a lot of ways in this front. We need it all across the grid. So we know that there's this notion of next generation procurement. And this is, you probably have seen some pieces from Alan and the Filecoin community about wanting to find ways to maximize the carbon impact of your decision making, so that you're not just dealing with this annual product that is not granular enough, wanting something a bit more granular. And so at SxSW, we realize that there's this issue where wind and solar is not being deployed consistently. We don't have enough growth in important technologies like battery storage because there's no market for it yet. There's no way to tag them in the way that I just explained. And there's no way to actually grab the real-time carbon data so that you know where you're buying clean energy actually has the biggest bang for the buck in terms of carbon mitigation. And so at the Clean Energy Buyers Institute, we have a new research initiative with leaders from across this space globally to solve two practical problems. How do we capture more types of data in these renewable energy certificates so that we can create more types of options for companies to move the grid in a certain direction in a more holistic way, not just more wind and solar? And then how do we make sure we have the right data so that we can actually fill in those new data fields on the certificates so we can make these new options possible? There's a lot of text here, but the main point is there are lots of things that companies want to do beyond the annual solar and wind purchase. For example, companies want to buy clean energy matching their actual time-based use of electricity. They want to, if they're consuming a certain amount of electricity right now at 11:25 Central, they want to buy clean energy at 11:25 Central. So that's one type of procurement option that's not standardized yet that we want to enable. Another is buying clean energy from the most carbon-intensive grids. For example, the biggest bang for the buck right now in the US, I believe, is the US Midwest and buying wind from the Midwest. So even if you're not located, say, in the Midwest, you might be somewhere else, that could be the biggest carbon bang for the buck. Similarly, you might want to buy more carbon-intensive products based on the time of day to send different demand signals so that we can power on solar or wind rather than a gas plant at a certain time. And companies are also trying to figure out how do they cover their supply chains, both upstream and downstream. How do they make sure the products they're powering their products and services with are clean? And how do they enable their consumers and users to source from clean energy? And so with this initiative, we just launched this. It's an open initiative, so anybody who's interested in participating to inform where this market should go, essentially informing the user stories we're developing for different types of clean energy customers, certainly welcome you to participate. We have our first workshop for clean energy buyers coming up later this month. So this is the end of the brief 101 on clean energy markets. So now let's go into what is the role of blockchain as a source of demand in the clean energy sector, before we then go into the solutions. So the crypto industry, most people know about it, or a lot of people know about it for just a couple of reasons, one of which is the energy consumption issue. I think it's really important to reframe this topic because everything we do in our world consumes energy. And the opportunity here is not to critique one source of energy use versus another, but to use it as a force for good to create those demand signals and buy more clean power, and pointing back to those images earlier, start to displace coal and gas and other polluting sources from the grid. And so there's a huge potential here, given the energy consumption of the crypto sector, to essentially become one of the largest types of buyers in the world, and to take a proactive stance and live up to a lot of the things the crypto and blockchain sector says that they're trying to do. This is an easy way to have a positive impact on the globe. And so for those who aren't familiar with this, less than a year ago, was involved with launching the Crypto Climate Accord, which is an initiative that says, as an industry, the crypto and blockchain industry, let's develop new technologies, new solutions using decentralized technologies to decarbonize the entire sector. So let's make the crypto blockchain sector green and build some awesome new solutions to get there, along the lines of what Alan was talking about before. And provide a couple examples. The one that Alan was talking about in terms of the Filecoin Green is phenomenal. It's the leading showcase right now for enabling the individual parts of a network to procure clean energy and prove it. But what's exciting is that this is expanding quickly into other parts of the crypto sector. So we know that there are Bitcoin miners, for example, who are looking at pursuing a similar solution, but in their case, it's looking at Bitcoin mining pools. So it's a way for pool operators to either cover the energy use of their entire pool with clean energy, to say we're a green pool, or provide a service for those miners to actually procure it and prove it for their own needs, whether it's for ESG investors and so on. Also, previously, 2 separate blockchains cover their entire global energy use per year with clean power, the XRP Ledger and Energy Web Chain. And what I've just talked about is on the supply side of the market, those who actually generate the cryptocurrencies themselves. And then if you look at the demand side, there's actually a lot of interest from those who invest or hold crypto. So what's exciting is that there are various crypto wallets and exchanges that are looking at how do we either cover the historic energy use of our crypto holdings with an equivalent amount of clean energy, essentially to send that positive demand signal to the industry. And then those who are looking to automate clean energy purchases based on the estimated energy use of crypto transactions. So anytime you make a transaction, it triggers a clean energy purchase, you get the proof. So it's some really exciting stuff that's emerging. Now let's go into some examples before I wrap up and potentially have some time for questions. So when you think about the role of blockchain and decentralized technologies in the energy space and to promote new tools for clean energy procurement, essentially the problem that it's really tackling is that with these certificates, it's one product, and somebody needs to communicate to several parties that you, in fact, are the one who owned that product, and that product came from a legitimate source. And right now, the way that information is tracked is across several organization systems that don't talk to one another. And so I think at the core of the value of blockchain-based solutions in the clean energy sector, it's solving these problems where we have multiple parties who all need to know the same information about one specific thing, in this case, the status of the ownership of a certificate. Because from there, you can create tools to embed this into any application. And when I think of, this might sound a bit simplistic, but when I think about, I'm often not talking with crypto folks like those in the room today. So when I think about blockchain-based solutions in the crypto sector, I think of an analogy of other things that we embed into apps. And I see blockchain and based solutions as just another layer in the technology stack of a clean energy application. For folks who are currently making transactions in the energy space, they're probably using Wi-Fi networks, Bluetooth to make the phone calls they're doing, HTTPS to run their websites, cloud storage to save components of their solution. And I see blockchain as one component that could be added to solutions to, again, verify the state of a given thing, whether that's a renewable energy certificate or something else in the clean energy space. So example one. So EnergyWeb is a leading global nonprofit. I used to work there before joining SEBA. And what they're focused on is creating digital identities for any energy customer and device. So that if it's essentially this notion of a single sign-on for you or me as a customer, or our electric vehicle, our battery, our solar panel, you name it. And the idea is it's then with one thumbprint or one digital passport, you can plug in as a customer into any app or service on the grid, and then the grid system itself knows who you are, and it reconciles all these issues that today live in different systems that don't talk to one another. Another exciting example, and it's one I'm involved with as a co-founder, is Xero Labs. So what Xero Labs is doing is tackling some of these next generation procurement topics that I brought up earlier in terms of where clean energy markets are going, solving specifically for the challenges of small customers who don't currently have a pathway to buy clean energy because they're too small to matter. And then more specifically, companies that have a large user or customer base where all of those users or customers use very little electricity for the actual transactions or their use of an app, but in aggregate can become quite large. So what's interesting about what Xero Labs is doing is building tools where you can aggregate really, really small uses of electricity, make it in a size that's interesting to clean energy sellers, enable sellers to digitize their supplies, match, and then using blockchain deliver proof of the certificates having been made available and canceled in the respective tracking systems. So it's essentially a way that from that complicated schematic I showed earlier for the whole life cycle of these certificates, Xero Labs the solution hides that complexity from the consumer. They just simply get a proof that they bought a certificate that was real, and they can send this demand signal in the market. And I think what's ultimately really exciting too, as we think about the future of clean energy procurement, it starts to automate clean energy purchases into the background of our apps. You don't have to actually do anything other than just saying, yes, I want to participate. Another exciting solution in this space for blockchain-based tools is a group called Flexadow, startup out of Europe. And what they're looking at is this notion of 24/7 time-matched clean energy, the point I brought up earlier. They're particularly working with corporations who say, as a corporation, some have a goal to say, I want to match the time of use electricity with a purchase of clean energy. And what they do is they use blockchain-based solutions to essentially show that there's been a reconciliation between the monthly data that become available for RECs and then the minute-by-minute energy use, where they can essentially use blockchain to show that all of these issues have been reconciled and delivered to the end corporate customer. The proof, because those companies want to be able to say that they're buying they're buying clean energy 24/7, and this is a topic that big, very notable companies like Google and others are prioritizing. So it's a really interesting space, and they're also tackling a lot of practical data challenges for how do you get that granular data. There's going to be some more talks about this later, and this is a bit outside of the clean energy space, but it's you can think of it as a brother in the climate solution space compared to renewable energy certificates. There are groups looking at digitizing carbon offsets and carbon removal. Carbon offsets essentially are a way to erase the carbon emissions of an action you make, versus carbon removal is with removing carbon from the air as it is. And so carbon offsets are an existing space. They have a certificate system just like RECs. Carbon removal is a new space that isn't standardized yet, but it's exciting. And both of these markets very much can use all the same things I was talking about today in terms of creating digital representations of the certificates, canceling them so that you know that nobody else owns the same certificate. And then there's some really fun applications to create more demand in this space. The last example for now, and this is not a technology solution, but it's in terms of lots of times technologies, of course, follow guidance and standards. And so there's a lot of exciting work by groups like RMI, where I also used to work, and they are looking at how do we redesign carbon tracking of our supply chains. Right now, if you're a company, you're trying to figure out what's the carbon impact of your supply chain, it is a mess. How do you know you bought steel from one company, rubber from another company, software from another company? How in the world are you supposed to come up with the carbon emissions from the top down? The idea here is to start tracking from the ground up, kind of in the same way that EnergyWeb is looking at the energy system, capturing the users from the ground up, so that essentially over time you can build it up and you can see exactly which components of the system consume or pollute a certain amount of carbon, so that it's then easier for you to make different choices and reduce the carbon across your supply chain. And what's interesting here is that this is another great example of using blockchain in this space. You have that stamp associated with each part of the life cycle of products as they go from the original form up to its end use. It hopefully will help make it really easy to figure out how much carbon you're responsible for and can cover either through clean energy and or offsets and carbon removal. So with that, thank you very much. Anybody who's keen to engage in the first initiative I talked about in terms of shaping the future of clean energy procurement and the standards and where the REC goes, because it is going to change to a certain extent, please reach out. We'd love to have a conversation and get you involved in these workshops we have coming. And then also keep an eye out on some of the solutions I was talking about. There's some really exciting work. And thanks again for having me.